Hello class, today I will be going over the 2011 AP Chemistry FRQ question number 6. Use principles of molecular structure, intermolecular forces, and kinetic molecular theory to answer the following questions. A complete Lewis electron dot diagram of a molecule of ethyl methanoate is given below. So the first question is to identify the hybridization of the valence electrons of the carbon atom labeled CW. So the hybridization of that atom is sp2 because it has 3 electron domains. Even though it has a double bond to the O, that still only counts as 1 electron domain. And then the second question is to estimate the numerical value of the HY to CX to O bond angle in an ethyl methanoate molecule, and to explain the basis of your estimate. So that bond angle is 109.5 degrees because the shape at that carbon atom is tetrahedral, which would make that bond angle approximately 109.5 degrees. And then for B, ethyl methanoate is synthesized in the laboratory form of ethanol and methanoic acid as represented by the following equation. In the box below, draw the complete Lewis electron dot diagram of a methanoic acid molecule. So just off of looking at the molecular structure of the HCOOH molecule, we can see that has an H in the front, which means it's an acid, and an H at the back, which likely means it's connected to an O. So we can start the Lewis dot diagram by first drawing this carbon in the middle, connected to a C, connected to an OH. Then we know that we have to follow the octet rule, so it would have to have a double bond to the second oxygen. And since there's only 4 valence electrons used on both oxygens, we have to have 2 lone pairs of electrons in order to complete the octet rule. And then for II, in the box below, draw the complete Lewis electron dot diagrams of a methanoic acid molecule and a water molecule in an orientation that allows a hydrogen bond to form between them. So we know that hydrogen bonds can form between a hydrogen connecting to a fluorine, oxygen, or nitrogen molecule. So there are multiple spots to do this, but I just chose this oxygen at the top right here, where it would bond to a hydrogen in an H2O molecule to form a hydrogen bond. And then on to C. A small amount of liquid ethyl methanoate was placed in a rigid closed 2.0 liter container containing argon gas at an initial pressure of 1 atm and a temperature of 20 degrees Celsius. The pressure in the container was monitored for 70 seconds after the ethyl methanoate was added, and the data in the graph below were obtained. It was observed that some liquid ethyl methanoate remained in the flask after 70 seconds. Assume that the volume of the remaining liquid is negligible compared to the total volume of the container. So I is to explain why the pressure in the flask increased during the first 60 seconds. So the pressure in the flask increased because the 2 substances reacted and created more moles of gaseous products, which in turn increased the pressure inside the flask. And then for the second question is to explain in terms of processes occurring at the molecular level why the pressure in the flask remained constant after 60 seconds. And it remained constant because at that point the system reached equilibrium, so no new products or reactants were formed, so the pressure did not change. And then the third question is, what is the value of the partial pressure of ethyl methanoate vapor in the container at 60 seconds? So we know the total pressure in the container at 60 seconds is 1.25 based off the graph, and then that the initial pressure of the argon was 1 atm. So if we just do 1.25 atm minus 1 atmosphere equals 0.25 atmosphere. So the partial pressure of ethyl methanoate is 0.25 atmospheres. And then the last question, after 80 seconds, additional liquid ethyl methanoate is added to the container at 20 degrees Celsius. Does the partial pressure of the ethyl methanoate vapor in the container increase, decrease, or stay the same? Explain. And assume that the volume of the additional liquid ethyl methanoate in the container is negligible compared to the total volume of the container. So the pressure would stay the same because the equilibrium vapor pressure has already been reached for 20 degrees and the temperature stays constant. So the pressure will not change at all. All right, thanks for listening.